Hi everyone, thank you for joining us for today's webinar, Visual Testing, the Missing Piece of the Puzzle with Senior Architect Gil Tayar. This is where I usually intro our speaker, but if I'll talk about all the amazing things Gil has accomplished in his career, it would take the entire hour and more, so I'll just give you the highlights. Gil is a senior architect and evangelist at Applitools. He has over 30 years of experience with software development, and in the past, he has co-founded Web College and worked on various big projects at Wix. His current passion is figuring out how to test software, a passion which he has turned into his main job as an evangelist and senior architect at Applitools. In addition, Gil is a sought-after public speaker, and he frequently talks at notable international conferences about test automation and software development, such as SeleniumConf, StarWest, STPCon, and more. And to top it all off, Gil is also a faculty member at Test Automation University. His course, Introduction to Cypress, is now available on the Test Automation University website, so be sure to check that out as well after our session. So I think it's best to let him speak now. Gil, the stage is yours.
Thank you, Adi. Visual testing, the missing piece of the puzzle. Let's start. I think Adi has it covered, but I do want to talk about something that has relevance to this webinar. It's the fact that I didn't join Applitools because it was a cool company and nice people and a great project, which it is. I did join because they were solving something that I thought was unsolvable. When I was at Wix, part of my job was working in the front end as a lead, and there we tested everything. I'm huge on testing, as you can probably guess, and we tested the buttons and everything. But one thing we couldn't test, and that was the visual aspects of our application. And I tried. I tried the way everybody tries to do visual testing, which is take screenshots every test and then compare them to the previous screenshots to see if anything changed. And I couldn't make it work. And why I couldn't make it work, we'll be talking in this webinar. But you know, I said, okay, I give up, and we did not do visual testing at Wix for my specific project. What's interesting is when I talk to Applitools and they're saying, yeah, we solved the visual testing, I was like, no. And then they showed me that they did. The important thing is, I had my puzzle. I had a testing puzzle, and it was all covered. There was just one missing piece. And that missing piece was about visual testing. And suddenly I found a solution that covers that missing piece. And this basically webinar is an explanation of why, first of all, we need that piece of the puzzle, and two, how would a solution that solves visual testing look like? So there we go. That's about me. And this, the first thing that, and I love to start talking about testing with a motivation, because testing is all about fear. Okay, and I'll show why. And I have to quote it. It's my favorite quote in all the world. It's a book called Dune. There's in next year there's going to be a movie about that book. So be prepared. And one of the more famous quotes is about fear. It's "I must not fear. Fear is the mind killer. Fear is the little death that brings total obliteration." Think of the extreme message that this brings, and it is totally true. When we fear, we don't do things. When we fear, we do things badly. We need to remove fear from our lives. We need to remove fear from development. We need to remove fear from production. And testing is all about that, and I'll show why. And let's talk about other kinds of fears. Well, we have fear of flying, you know. A lot of people have. I always when the plane lands, I always have this little bit of fear. Oh my God, what's going to happen? But up to now, it's been okay. Fear of heights. I have to admit, I have a little bit of that also. Fear of approaching that cool guy. Well, that's not my problem, but a cool girl it was definitely a problem. Happily, I'm now happily married, so I did approach the correct girl. And fear of public speaking. That's number one fear of most people, not my fear, as you can see. But Yeah, okay, those are, like general fears that everybody has. But as software developers and people dealing with software development, what are software development? What are part of them? And I want to talk about that. One is fear of adding code. I have a feature that I want to develop. The product needs a feature. The software developers go in, and the feeling is that they're just adding code. But we all know that's not true. And what usually happens is that we add code and everything breaks, or parts of the thing breaks. Something that shouldn't be a problem, deleting code. I mean, sometimes we delete the code and everything's fine. But sometimes, as this poor boy found out, it breaks a lot. And the last one is refactoring. Sometimes we want to make code simpler, easier to understand, better, more maintainable, but we do a lot of changes and it completely breaks everything, as this cute cat found out to its surprise. So fear of adding code, fear of deleting code, fear of refactoring, basically fear of changing code. Those are the biggest deployment fears, development fears, and we'll talk about other software development fears. But I want to concentrate first of all on these fears of software development. And why? Why do we fear adding or deleting or refactoring? We talked about that, but it's basically because we're really bad at what we're doing. Developers are really, really, really bad at developing software. We can't add one line, or we can't delete a single line or change a single line without it breaking anything. And my CEO of like 5 companies ago said, and I always quote that because I think it's a beautiful and funny quote: all software is a harmony of bugs. It's not that there are no bugs in our code, even if it's a working product. It's that the bugs like coexist with one another a lot of times, even in the best maintained code. There are always bugs there, and sometimes those bugs cancel each other out, and everything works because somehow it works. And sometimes when we change something, that balance is overcome. So, okay, we're bad at what we do. Anything we change, if we change the code, a lot of times things break. How do we overcome that? Well, obviously, we write tests. Let's talk about which tests before talking about why testing overcomes fears. So the first thing that developers write, especially when they're new to software development, is unit tests. What are unit tests? Unit tests are tests that, it's code, first of all, code that tests a specific class, a specific function, or a module, or a UI component. Okay, it's just one unit. If we're running function, if we're doing functional programming, it'll be a function. If we're doing object-oriented programming, it'll be a class, etc., etc. And we just test it in isolation. It's the easiest test to write because it's just one class. You put in the information, you make it run, and then you check the output of that function or class or whatever. Those are the easiest, fastest, nicest, not flakiest kind of tests. Love writing them. So if we're talking backend, the backend has unit tests. If we're talking front end, the front end has unit tests. So those are 2 pieces of the testing puzzle that help us overcome our fears. Let's continue. Okay, so unit tests are great, but why can't we only have unit tests? Because if unit tests are so great, let's write tens of thousands of unit tests and then deploy our application without fear. And the answer is simple. Most of our code is glue. It's not the logic. It's gluing the logic together. It's gluing the components together. It's gluing whatever. About 70% of our code is gluing those units, those logic units together. And sometimes this is a classic GIF. Sometimes the units work, but together they don't. This is a classic case of unit tests 2, integration tests 0. There are others that you can find a lot of these on the internet if you look for them. Pretty funny. So how do we solve that? Well, the answer is we write integration tests. What are integration tests? Integration tests are tests, code, that runs and tests a set of units functioning together, just like they are functioning in the application. So now we're not just taking one unit, we're testing a lot of them together. For example, an extreme case would be, not an extreme, a regular case would be in front end, for example, taking multiple components and gluing them together just like they are in the app and testing it as a whole. An extreme case would be testing the whole front-end app, but without the backend. Okay, if it's with the backend, it's a different kind of test, but without the backend, or testing one page of the application, let's say the login page, that's still an integration test. In case of backend, integration test would, if our architecture is a microservice architecture where our application is divided into lots of microservices, is testing one microservice without running the other microservices. So integration tests are great because they enable us to test a lot of units together and see how they perform, like almost in real life. And yet they're not huge end-to-end tests. They're still integrated and pretty small. So what kind of tests? Backend services tests, where we test a microservice. Sometimes we need to test the backend microservice or whatever app. Just test the integration with a database. That's also a kind of integration test. And testing the front-end applications, either big component by big component, or testing pages as a whole, or in extreme cases, testing the whole front-end application without the backend. Okay, so 3 more pieces of the puzzle. Well, I want to stop here and talk about how testing overcomes our fear of software development. Okay, so we saw tests, we saw the fears. How does this work? And you're probably familiar, and I'll show the flow. A developer codes, right? She writes the code for the application and continues writing the code. The test, she writes the test for the code. So while writing the code, she writes the tests for the code, and it doesn't really matter if it's writing before she's writing the code or after, TDD style or not TDD style. The point of writing tests is writing it as part of the coding until it works. So how does the developer know that it works? She runs the tests. If they pass, the code works. What happens if the developer adds code or deletes code or refactors the code? Well, she just runs all the tests again, and boom, success. If it fails, she finds the bugs, fix it. If she succeeds, she knows that everything that already worked is working again. That's the basis of overcoming fear. And I always like to, people ask me about coverage. Okay, how much coverage do you need? Do you need 90% or 70% or 95%? What is the good coverage for tests to have that confidence, to abolish fear? And I always, well, there are companies that use coverage testing how much the tests cover. I always like my shakeometer. My shakeometer is is the way to figure out how if I have enough tests to overcome my fear. And the shakeometer is simple. It's a device that's connected to my wrist and checks how much my hand shakes whenever I deploy. It's that simple. If my hand shakes when I deploy, I go back and write some more tests because I'm not confident. My hand, my mind, my heart know much better than I do whether I have enough tests or not. If my hand does not shake, if my wrist does not shake, good, let's go and deploy. It's incredibly enough, it's pretty reliable. Obviously, there is no shakeometer. It's a metaphor, but the intuition and the feeling is definitely there. Okay, so we talked about back end and front end. We were testing our code, so we have like 95% coverage. But are we really testing the whole code? I mean, front end, all the front end code, all the back end code. Are we testing everything? And I always ask people, are you testing everything? And they say, yeah, we have 95% coverage. And then I ask them, yeah, but are you testing your HTML and CSS? What happens when you change your CSS? What happens when you delete a rule because you're absolutely certain that that rule in that CSS file does not work, is not needed? Do you have a test that covers that? And then they go, you're right, I have no tests for that. And what about HTML? What if you change, you have these templates or handlebars or React code? What happens if you remove a div or add a div or do all kinds of stuff? Are you testing your HTML? Does it look as it looked before? And they're going, you're right. We have no tests, neither for HTML nor for CSS. And the reason people are surprised, I would be like, of course you have to test everything. But a lot of people are surprised because they don't think of the visual aspects as something that can or should be tested. But it's the same fear. I mean, fear of deleting a CSS rule is exactly why CSS files are so huge. We have so much stuff in there, and we are totally afraid of removing one single line because we have no idea what pages it affects and whether it affects anything at all. So we fear adding CSS rules, we fear removing CSS rules, and we fear, and the most important fear, we fear refactoring our CSS, and the same goes for HTML. The fear exists. It cannot be denied. So we're testing backend, we're testing everything, not a problem. Okay, if you have good tests, your backend is covered. What about front end? Yeah, we're testing the logic code, we're testing the component code, we're testing the HTTP fetch code that brings the data from the backend server, but we're not testing the visuals. We're not testing component by component, like unit tests for component, but visual. And we're not testing the whole application integrated together to see whether it still looks okay. So, yep, two missing pieces of the puzzle: component visuals and application visuals, which obviously brings us to visual testing, sorry. And it's two main ways: component testing and application testing. And it's we'll see it's the same tools used in both, but in slightly different ways. Let's start with components. How do we visually test our components? When I'm saying components, I'm talking about if your company uses React and React components, if they're using Angular components, Vue components, Polymer components, whatever component library you have, how do we test the date picker in that library? How do we test the button in that library, the search bar in that library, the menu in that library? How do we test those to see that they're still okay, that changes in the CSS didn't affect them? And the answer is simple. Well, it looks simple. We built a demo app, okay? We have a component library, so we build a demo app that includes all the components in the library. Basically one page or like 10 pages or whatever, and each page has lots of components in it. So basically all the pages will have all the components inside it. And not just the components, but various states of the component. That's the terminology. For example, a checkbox, I will have two states, one unchecked and one checked. So once we have that application, we have multiple pages with all the components inside of them in all their states, we run a browser. We run a browser like Chrome, Firefox, whatever. And for each component, what we do is we take a screenshot of that component and we compare it. What do we compare it against? We compare it against a baseline screenshot that we know is good. How do we get that baseline screenshot? Simple. The first test we run, the screenshots taken are used as the baseline. So obviously after we run the test the first time, we go through all the screenshots like with a viewing glass, and we check that everything's okay. And we give it to the designers, and they check that everything's okay. Now these are the baseline screenshots. The next time we change our code, we run the tests again, compare the screenshots against the baseline. If they're wrong, well, if there's no diff, boom, the test runs the test passes, everything's good. If there is a diff between the baseline and the current screenshot, well, it could be one of two things. Either it's a bug or it's a feature, as usual. A bug meaning, yeah, I did something wrong. The application doesn't look as it should. So I fix the bug and the test passes. Run the test again and the test passes. But it could be a feature, as in, yeah, the designer wanted the button to be a little larger or a different color, or there's a new button in the page. Who knows? So what we do is we change the baseline. We now take the current screenshot and make it the baseline screenshot. Perfect. Okay, let's go over each one of them and see that it's, well, not simple. Possible, but not simple. So let's talk about building a demo app that includes all the components. It's not easy. So yeah, you have your, as a front-end developer, you have all that configuration because you're using modern tools, Angular and React and Vue, and they have all these Babel and Webpack. So now you have to recreate all that configuration in a demo app. Not easy, but there is a solution, and it's a wildly great one, and it's used by a lot of companies to showcase their component library, and it's called Storybook. And the idea is that with just a few lines of HTML and JavaScript, we get all our components in a nice UI where I can navigate and see all the components in all the states. And the code, the JavaScript code that generates it looks like this. And this is for React, but for Angular, it's pretty similar. So I say the stories of header. There are two stories, it's called. It's categories, basically. One with a header with no user. That's this one. And the header with a user, and this is, as you can see, it accepts a user. And login, I have an empty login page and a login page with text. So this is an example storybook code. And this looks like this, something like this. When I run the storybook, when I execute this code and run the storybook, it gives me a UI like this. This is actually an old version of Storybook. Now it's much nicer, but it's basically the same. I have the two stories, header and login. Categories, header and login. As you can see, the two stories, no user, with user, and empty and with text. And let's look, and let's say I click on the no user. I see the header as it is when there is no user logged in. And if I click on with user, I can see the header as it is when there is a user. Same for login, empty login page, where I see email and password, I see the placeholder for that. And with text, non-empty placeholders and the sign in button. Perfect. So this is how Storybooks looks like. You code something. You code what the components you want to show. You run the Storybook thing, and up pops a UI, which enables you to see all your components in all their states. Very, very cool. Highly recommended. So we built a demo app that includes all the components using Storybook. Pretty easy. Now running a browser. Running a browser, well, we all know. Selenium. Some people like Cypress. Some people like Test Cafe. What else is there? There are pretty much WebDriver, IO, etc., etc. Whatever you choose, it's basically similar. Before the tests run, you create a browser. I'm using JavaScript here, and after you kill the browser pretty nicely. And now for each component, we need to take the screenshot and compare it against a baseline. So taking a screenshot, how do we do that? Let's look at a test which checks that the no user header looks okay. I go to I click the no user. Remember, on the left there's a navigation pane. So I click on the no user, and on the right I will see that component, and I take a screenshot. Selenium has to take screenshots, Cypress has to take screenshot, Puppeteer has to take screenshot, Test Cafe has to take screenshot, everyone. And then I check. We have hundreds of open source libraries, well, tens of open source libraries that compare screenshots against, baseline screenshots. I use, I don't even remember what I used here. Same for with user. Here you can see. And yep, sounds perfect. We have overcome our component visual fears. I write some code, pretty easy code, and boom, I have visual testing. Unfortunately, there's an elephant in the room, actually 4 elephants in the room. And we'll go over one by one, and we'll see where the problems in visual testing are. And it's exactly, sorry, the problems I had at Wix when I tried to do visual testing and failed. Setup is difficult. Setting up and tearing down Storybook is more difficult than it seems. You set up, you run Storybook, and then you try and tear it down. You get orphan processes which don't tear down, and they occupy your port. It's a mess. Running a browser is a core. If I want to run it in CI, I need to run it headless, etc. There are better solutions for that. But what if you want to run it in IE, and you want to run headless or whatever? Now you have to have a VM farm to run your tests. It's a mess. But the big problem, I mean, those are problems, but we know how to solve them. They're messy, they're big, they're expensive, but we know how to solve them. The problem I had at Wix, which I could not solve, is this. I got flakiness. Every time I ran the test, not every time, but if I ran the test, pushed to Git, and my colleague ran the tests, he got errors. He got diffs between the baseline and the screenshots that he took or she took. And then she changed the baseline by taking her screenshots and making them the baseline screenshots, and now I run the test and boom, I get diffs. The problem is I try to compare things that are identical, no change in the code, and I get a mismatch. I'll show you why. You can see here, this is, you can see below, there's a menu with my videos, discovery, playlists, etc. on one Windows machine with a specific graphics driver. I have no idea which one. And another machine with a different graphics driver. As you can see below, you can see the zoomed out. Below, it looks good. It looks exactly the same. For a human eye, obviously, it's exactly the same. But each graphic driver has slightly different anti-aliasing thingamajigs. I'm not a graphics expert, but every graphic driver, every operating system, every browser, every little thing changes the fonts and the images just slightly different. And if I have if I do pixel comparison, I get false positives. So one does not simply do bitmap comparison. Pixel by pixel basically doesn't work. And that was the problem I had at Wix, and that is the problem I could not solve, and that is why I threw all the code away and just did manual testing for visual. But there are more problems that around image comparison. Sometimes the images are scaled. Sometimes, believe it or not, the same browser will move by 1 pixel offset because of rounding errors or whatever. What about dynamic content where there's a date somewhere in the code? Oh, I won't get into that. I want to show another pixel difference. This is Chrome. On the left is Chrome 67, same JPEG as on the right, Chrome 68. Do you see a difference? I do not. But if I do a pixel diff, the reds, the bright reds, are the diffs between them. Chrome 68 changed the way it renders JPEGs. And I got like almost 50–60% diffs on this single image. Another one, this is Angie Jones' test automation demo, and I ran it using a pixel matcher, and this is one, and this is another. Do you see any difference? I don't. But look, oh, I didn't bring in the real one. What I saw was on the same computer, on the same graphics driver, operating system, everything, but like 5 minutes apart, there were like about 20–30 pixels that were different. Why? I have no idea. Okay, so that's the problems of pixel matching, and they are the worst. Another problem is baseline administration. Okay, so let's say I find a diff. I find a diff in like 5 screenshots, and the diffs are good. It's not bugs, it's like features. It's like changes that are good. I want to update my files. So given that the screenshots are files on the file system, what I need to do is I need to copy from one folder process screenshots to another folder expected screenshots. That is how I update my baseline, which is fine if you have 5 screenshots. But what if you have 300? That becomes a core, finding the correct file, copying it over. Not very nice. Performance. How do we scale this? I mean, I have 5 components, I have 10 components, I have 20 components. I'm good. Whatever the performance is, it'll be okay. But what if I have hundreds of components? What if I have hundreds of components and each has 3 different or 4 different or 5 different views? We've seen storybooks with 1,000, 1,500 components. We've seen storybooks with 3,000. That was extreme, but definitely it's there. That test, if I use this method, will take tens of minutes, half an hour, sometimes 3/4 of an hour or an hour, depending on your infrastructure. That's a problem. Developers don't like to wait. Testers don't like to wait. A test that runs for half an hour, not a good sign. What's the solution? Well, there are solutions, and the solution is commercial grade SaaS tools, things like Applitools, and I will be showing Applitools. They have solutions to each of these problems. Unfortunately, and I love open source does not yet offer a complete solution to these kinds of things. They're okay, but definitely pixel matching, you need to copy folders and everything. Everything is like, yeah, fine for 10 components, but once you go over to hundreds of components, you have a problem. So let's talk about the solutions to each of these problems. Let's talk about baseline administration, where you have to say, yeah, this baseline is different, and it's okay. So what Applitools and other tools do is they upload the screenshots to the cloud and give you a nice GUI to to see the diffs, first of all, and to accept the diffs. You can see there's a nice like button. The like button says this diff is okay, please update the baseline. So a GUI is very, very necessary. A SaaS tool where everything is uploaded to a place where you can see the GUI, that's incredibly important for real visual testing. What about flakiness? Here come the smart people. Fortunately, today we have solutions where diffing looks not at the images, not at the pixel level, but at the human eye level. It looks at the images as a human eye would, ignoring those little differences just like a human eye would do. And the way we do that is with the new AI algorithms. We use advanced visual algorithms, and we mix them with machine learning and deep learning stuff to make it, to have the result is no flakiness, no false positives, because it's looking as a human eye would. So if you get a diff, it's probably a diff that the human eye would notice, like not 1 pixel, but much more. But you also get enhanced capabilities, which I don't want to get into, like layout mode, ignoring regions, etc., etc., etc. What about setup? As I said, use a good Storybook SDK, and then you get a no coding experience. So if you already have a Storybook or you're building one, Applitools has SDKs that enable you to just say, test the Storybook, and you're done, no code, and you've tested all your components. What about scaling to hundreds of components? And the answer is, we have a cloud. We don't push the test to the cloud because that's expensive, but we push the rendering, taking the screenshots to the cloud. What we do is, instead of taking a screenshot during the test, we take all the DOM, the HTML, the CSS, the SVGs, the GIFs, the PNGs, etc., fonts. We upload them to the cloud and we recreate the page, but we don't do it serially because we have thousands of browsers at our disposal. We do it in parallel. So if I have 1,600 components, 1,500 components, and I want to test them in 3 browsers like Chrome and Firefox and IE, and that's not a problem. It can be finished in like 3-4 minutes because everything is parallel. So yep, we've solved the component visuals. What about application? How do we test an application? It's basically similar. We run the app, run a browser, drive the app along the flow we want, as we said. But in this case, we're not testing a storybook, but we need to click, click, click to get at the pages that we want. And we remember, we're running, we want to test the whole application. Take screenshots along the way, and as usual, compare against the baseline. Something like this. So driving the flow is simple. We click, click, click to register a user. This is a blog app. We publish a post, we log out, we do whatever. And along the way, we use check window, just like, or whatever comparison tool we have to check the screenshots. So similar problems, besides setup, because we already have the app, similar solutions. So boom, we've solved two pieces of the puzzle, component visuals and application visuals. Let's talk about other fears, because fears of development, we've solved. The puzzle is solved, but there are other fears connected to software development. One of the fears is fear of deploying. Deploying itself is a fear. And how do we overcome that? And the answer is we write end-to-end tests, full end-to-end tests, because up till now we were talking about integration tests mostly. End-to-end tests test everything, the front end with the back end, all microservices together in an environment that is as close to production as possible. And the theory is visuals are covered, by integration tests, so no need to cover them in end-to-end tests. But the reality is most front-end testing is not done by front-end developers, it's done by the QA automation team. But it's similar problems, flakiness in tests, at least visual, baseline administration, scaling to hundreds of pages, and the solution is similar. So end-to-end tests and end-to-end automation visual tests, we've covered more pieces of the puzzle. Now, once we deploy, that shakeometer shows us our wrists is not shaking, and our visuals and our backend and our front-end logic is covered well. What other fears do we have? Well, fear of problems in production. Okay, so I've deployed. What now? And well, let's talk about backend production problems, hardware node problems, networking problems, database problems, scaling problems. And the solution here has nothing to do with visual testing. It's observability. You log everything, you monitor everything, and if there's a problem, you alert and notify someone, and they rush to the to the terminal and fix the problem. But okay, that's mostly backend. What about front end? What front end problems could there be because it's all been tested? And the answer is data problems. We've tested on a specific set of data, but in production, data can be everywhere. This is an example from, I don't remember which page. As you can see, Bounty Essentials looks good. Bounty Essentials Select the Size paper towels looks bad. That's a visual bug. How can we visually test this? Well, it's a problem because we can't do comparisons of product pages using baseline methods because we have thousands and tens of thousands of product pages or whatever you have in production. You can't do pixel matching here because you don't want 10,000s of baselines. And the answer is layout testing. You check the layout of the page while ignoring the data. That is also possible using commercial grade software tools like Applitools. And this is actually where machine learning really, really shines. So production problems, production observability solves our backend stuff. Production visual layout, where we test the production using visual layout algorithms, that solves our data problems in the front end. Another front-end problem, well, not only front-end, is fear of hacking. What happens when hackers get into your system? How do we overcome the fear? Well, backend usually do penetration testing. Backend people usually do penetration testing to check whether hackers can penetrate into their system. There are companies that do that. Perfect. But what about site defacing? Usually, the corporate site is not as well protected as our applications, unfortunately. It's a WordPress, and WordPress hackers have way to override this, and they love to deface sites. This is an example from one university in the Philippines where Anonymous hacked their site. Another one from God knows where, oh, Utah, sorry, hacked by Muhammad Ahmad, long-lived to Peshmerga. I have no idea what that is. And another one, I can't see, but it's defaced here somewhere. Anyway, and it's, as I said, it's the corporate sites that are usually defaced. How do we do that? How do we solve that problem? And the answer is we do corporate site visual testing. We go to those pages, and mostly front end page, home pages, and one level deep pages, and we visually test them. If every 10 minutes, every hour, every day, we do a visual testing on those pages, well, we've covered site defacing, because once there is a diff, we can rush, check that the site is defaced, and restore from a backup or whatever. And there we go. We've solved the missing pieces of the puzzle in all their various facets. Fear of hacking, fear of production problems, fear of deployment, and fear of changing code. And you can see that all the time there were missing pieces to that puzzle. Component visuals, application visuals, end-to-end visuals, production problems with data visuals, and corporate site defacing visuals. And those were missing pieces. But now we have those solutions that enable us to solve that problem in a good way. So yay to visual testing. And if you come out of this talk learning one thing, it's this, and I always end my talks using this. I must not fear. Fear is the mind killer. Fear is the little death that brings total obliteration. I will test my code and visually test my code. I will permit it to pass over and through me. And when it has gone past, I will turn the inner eye to see its path. Where the fear has gone, there will be nothing. Only my visual tests will remain. Write tests, write visual tests, overcome all your fears, and don't forget to test the visual parts. Great success, and thank you very much. Oops. There we go. Okay.
Are we ready for questions?
Okay. Yep,
Yeah?
I'm definitely ready.
Okay, great. I think this was the first webinar with an image of Borat, by the way, filming.
I'm a huge fan.
Yeah, that makes two of us. So first question, which approach is better? Writing tests before writing the software, or writing the tests after we code?
One of the greatest questions. Well, it depends on the granularity of the before or after. From my point of view, while writing the software, you write the tests. Now, a lot of people like TDD, test-driven development, where they first write the test for the code they write, then write the code, then write the test, then write more code, then write the test and write some more code, etc., etc. But the granularity here is usually the unit granularity, and it's not like they're writing the whole test for the whole application and then they're writing the whole application. It's not like 2 months of writing tests and then 2 months of coding. It's like 1 hour of test, 1 hour of code, 1 hour of test, 1 hour of code. I'm not a huge fan. I prefer doing it wild. So I write some code, I write something that works, I refactor it a little bit to make it look nice, and then I write the tests. But I'm not like waiting 5 days and then writing the tests. It's not a separate part of I don't go to my manager and say I'm writing the code and then I'm going to my manager saying now I'm writing the test. It's all one big thing from my point of view. Writing code and writing tests, it's just the same thing. Yep.
So we got a few questions. I think this one is the most holistic one. And they're asking about visual testing. I think it's specifically to Applitools, but I'm not sure. They're asking, can this be done for any app, or is this just for a web app?
Visual testing is best done for web apps, but definitely anything you can take a screenshot of, you can visually test. So we have mobile SDKs where we take screenshots of mobile apps. Definitely something. I know of game companies. That's crazy. That visually test their games. I have no idea how, but they definitely do that. TV companies like Netflix do visual testing on their TV software, etc., etc., etc. So yeah, web is the easiest and the most supported, definitely, but other apps are definitely visually tested.
Can we define, can we test or visually test or define baseline images from an image, not from a web, and compare those?
I think the question is, let's say a designer gives you an image, and that image should be the baseline. Well, in theory, you can, and if I think about it, I think we can do it in using Applitools SDKs. But in practice, it never works. There's always some difference in where the button is laid out in the image, etc., etc. So in theory, it's a really cool idea. In practice, unfortunately, it doesn't work. What does work is once you run the tests, you link to that test, send the link over to the designer, and they go over it with a magnifying glass to check that everything is fine.
What is the difference between visual testing and DOM-based testing?
Great question. For example, Jest has what is called snapshot testing, where they compare the DOM of the component before or after. Well, it does test your HTML, definitely. But first of all, a lot of times you change the HTML, but you want to see that visually it's the same. DOM snapshot testing can't test that. They test that the DOM hasn't changed, which is important, but they don't check that the visuals haven't changed. So yeah, but what they never test, and they cannot test these kinds of tests, is the CSS. If you change the CSS, DOM snapshot testing won't know about that.
So can visual testing only help you test the graphic user interface or user interface, or can you use it for functional testing? Can it replace functional testing?
Well, you can't replace totally, but you can definitely do, and we have customers that do it. You can definitely do it using as replacing the validation part. So a functional test usually does click, 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 and then check that this element has this value, and this element has that value, and this element, etc., etc., etc. So you have like 3 actions, and then lots and lots of validations to check that those actions generated the correct result. Instead of all those validations, you can just take a screenshot. Take a screenshot, compare it against the baseline if it's the same, and you would be surprised how many more bugs you find, because when you're doing validation element by element, you're not going to check all the elements. That's like tens of lines of code. Nobody has the ability to do that. But a screenshot validates everything. So you're covering everything in one line of code. So definitely functional testing can be aided by visual testing.
How do we do visual testing in different screen resolutions? Won't it always fail?
Yeah. Well, if you compare, 1024 to 1280, obviously it will fail, even if it's not pixel matching and it's good visual comparisons. But the way all tools deal with it, all commercial grade tools like Applitools deal with it, is they have separate baselines for different viewport sizes. We call them viewport sizes. So the baseline image for 1024 will be different than the baseline image for 1280. Definitely. And if you're using, the grid capabilities of Applitools, like, for example, if you're using the visual grid, you can do component testing or app testing and ask Applitools not only to render them in Chrome and Firefox and IE, but you can also say, please, in Chrome in 1024 and 1280, in Firefox in 800 and 1024, etc., etc., and it will render them in the same time it would render like one width. So definitely it has to be different baselines.
So we have, I think, an Applitools specific question here. Someone is asking, how would you test a website with a lot of pages? Wouldn't that create a lot of baselines, different baselines within the test?
Of course, again, if you're talking about a lot of pages that are the same, for example, product pages, then in this case, I would create one baseline and check all the product pages against it using layout, not using, you know, what we call strict, not checking the data, but checking only the layout of the pages. But if you have different pages and lots of different pages, then definitely check each one of them, have each one of them have a different baselines. Applitools and other tools have ways. For example, Applitools, if you change the header, the logo in all the pages, you can like press a button and it will take all those, you know, hundreds of diffs and collapse them into one diff, which says all these diffs are the same diff. You can just check one and everything will be okay. So yeah, we have tools that deal with scales of hundreds of baselines.
How effective will visual testing be for React.js or Ember.js applications, dynamic UI?
Very, very much. I mean, most of our customers have applications and that, you know, that applications as in dynamic. I love React, and I've used visual testing extensively to check React apps. It's perfect, and no problems there.
Someone is asking, what about code coverage?
Code coverage tool. Oh, sorry. Yeah.
No, that was it. What
That
about
was the
code
question. That was the question.
That
Well,
was the question.
as you probably heard, I'm not a huge fan of code coverage, but I know that a lot of companies use it, and I totally understand why. I mean, it's a question of style. Code coverage tools like I'm a JavaScript person. How's it called? NYC. I don't remember the name. Are great. They work. You need to use them. This has nothing to do with visual testing, but definitely if they work for you, it's a way of you know, ensuring that developers write tests. It's like the whip. You wrote code and you didn't write a test, your code coverage will go down, and if it goes down below a certain threshold, boom, your tests won't pass, and you will have to write that test. There are good sides and there are bad sides to it. It's up to you.
What is the overhead in terms of maintenance for doing this sort of visual testing?
Just like any other test. I mean, I write tons of tests, and you know, if you're coming from QA automation, you write tons of tests, and all of those functional tests have to be maintained. There's nothing to do. Just like you maintain your production code, your code. Thus, you need to maintain your tests. There's no two ways about it. Not as much as, but definitely maintenance is there. Same goes for visual testing. You know, you have to maintain your visual testing code. Sometimes you need to maintain your baselines. Same, no difference. If you need to overcome your fear of visual changes, you need to do visual testing, and it comes with some level of maintenance. There's no two ways about it.
For multilingual applications, is it enough to test only the layout of the application, or is there any more effective way with visual testing?
Yep, that's what people do. They do layout testing for that. Some people like use different baselines for each language. For example, I know a company that uses it to check not for visual bugs, but to check if the text has changed. And if the text has changed, they alert, you know, the copywriters. And oh, sorry, if the English text has changed, then they alert all the others, and all the other texts get translated. All that specific text get translated into the other language. So they're using it not as a visual testing tool, but as a monitoring tool, funnily enough. But yeah, layout is perfect, and a lot of our customers are using layout mode to do translation testing.
Okay, I think I saved the best for last. Last question of the evening. In your opinion, who should be in charge of those visual testing, the developers or the QA, the testers?
Whoever is in charge of, from my point of view, whoever is in charge of front-end testing. If it's only the front-end testers, then the front-end testers should do visual testing. If it's only QA people, then the QA people should do it. If it's a mix, then the same mix, the same decisions as to who does what should be applied also to visual testing.
So unfortunately, that's all the time that we have for today. I want to thank all of you that joined us for this live session, and of course, thank our speaker, Gil Tayar. Before I will let Gil have the last goodbye, I'll just want to do two quick reminders. The first one, Gil's Cypress course is now available on testautomationuniversity.com, so be sure to check that out, as well as other great free online courses offered there. And the link to the recording of this session will be emailed to you by end of day Thursday. And I hope to see you all at our next event.
Thank you, everybody.